So this is lesson 3.5, and we're going to be learning about some reasons that we can prove lines are parallel. So we've already talked about what corresponding angles are, but the converse actually proves lines are parallel if we have corresponding angles that are congruent, then the lines are parallel. So we call postulate 3.4 corresponding angles converse. So if given the line and a point not on the line, then there exists exactly one line through the point that is parallel to the given line. So let's read that one more time. If we're given a line and a point that's not on that line, then there does exist a line through that point that is parallel. That's called the parallel postulate. A couple others, which shouldn't be too new since they're going to be using some of the terms that we've already been using in this chapter. Alternate exterior angles converse. So that says very similar to our corresponding angles. When it's the converse, it's proving parallel. Okay, so converse proves parallel. Now, if we have alternate exterior angles and they are congruent, then those lines are parallel. Consecutive, we're going to change that again to same side interior, if you like that better. Same side interior angles converse. So if we have angles that are supplementary that are on the same side, the converse tells us then those lines are parallel. So we can use our angles to help prove that the lines are parallel. Alternate interior angles converse, as well as perpendicular transversal. Let's take a look at that one. That one is a little bit newer than our previous ones. If two lines are perpendicular to the same, then they are parallel. So two lines perpendicular to the same line, then they are parallel. Okay. All right, so let's go ahead and take a look at a couple of examples here. The first one, if we're given that angle 1 is 103 and we're given that angle 4 is 100, is it possible to prove that any of the lines shown are parallel? If so, state the postulate or theorem. Well, these would be considered alternate interiors, so they would need to be congruent in order for us to use the alternate interior angles converse. So since these are not congruent, the answer is no. The measure of angle 1 does not equal the measure of angle 4. So A is not parallel to C. All right, 1 is congruent to 3. So 1 is congruent to 3. Well, if those are congruent, those are corresponding. So yes, by the, we'll say A is parallel to B by the, and you could say corresponding angles converse or converse of, either is fine. Converse of corresponding angles postulate. All right, next question here. Got some standardized test practice. This one, these are alternate exterior. So it says find ZYN so that the lines are parallel, PQ and MN. So if these are congruent, then that would prove these lines are parallel by the alternate exterior angles converse. So let's go ahead and solve, setting them equal. So we can find angle ZYN right here and use that information. And add 25. So 4x is equal to 60, so x is equal to 15, which if we are going to plug it back in, 7 times 15 plus 35, that's going to give me 95 plus 35, and that's going to give me 140. Nope, 130. Mental math. Degrees. All right, so next one, we're going to start off with what we are given, and then lastly, what we're trying to prove. So go ahead and fill those pieces of information in. All right, next we're going to look for anything else in the picture that we can go ahead. So we know 1 and 3 are congruent, that's given to us, but what about 1 and 2? 1 and 2 are corresponding, and if we know that these are parallel, corresponding angles are congruent. So we can go ahead and say that angle 1 is congruent to angle 2 because we know they're already parallel here, and that's corresponding angles. Now that's not the converse, because remember, converse always proves parallel, and we're just proving angles congruent. So now let's go ahead and see, we need to prove P and R. So we need some sort of relationship of 2 and 3. Well, this information uses 1 and 3 and 1 and 2. So we could put 2 is congruent to 3 by the transitive. And then 2 and 3 are alternate exterior. And if we have alternate exterior, the converse will prove parallel. So alternate exterior converse. Okay, proves parallel. All right, this next example here, we've got a carpenter creating woodworking pattern here, wants 2 pieces to be parallel. So these are same side interior, so they need to be 180 for these to be parallel. So if x is 15, show pieces A and B are parallel. So we need to, if we're going to try this, we need to add these up and set it equal to 180. And so I think it's saying, would x being 15 prove that? So let's go ahead and check. So we know they have to be supplementary though in order for those to be parallel. So 10x is equal to 150 and x equals 15. So yes, by the same side interior angles converse, they would be parallel. All right, so let's take a look at this next one here. So this one, we are going to, let's go ahead and set it up as kind of a column, 2-column proof here. So we have angle 5 is congruent to angle 6, and angle 6 is congruent to angle 4, and that is given. The next step is going to be, well, let's see, what do we have? We don't have anything in our picture that we can use, but we do have, well, these both are congruent to 6, so that means that angle 5 would be congruent to angle 4 by the transitive property. And then if we know that 5 and 4 are congruent, then we can say the lines are parallel, which is what we're trying to prove, by its converse. So AD is parallel to BC by the converse of alternate interior angles. So converse again proves parallel. Converse proves parallel. So if you need to say that to yourself a couple times, that definitely helps. We got to make sure that we put that converse in there. That's what proves parallel. So in this next one, let's go ahead and fill in what's given. M is perpendicular to P and M is perpendicular to Q. So if it's perpendicular to both, then we can actually jump to saying that those lines are parallel. So 1 is given, but 2 is using the perpendicular transversal theorem, or converse, converse, because converse proves parallel. So the perpendicular transversal converse, if 2 lines, if one line is perpendicular, if they're perpendicular to the same line, then those lines are parallel. That's what that converse says. All right, the last one, these are alternate interior. In order for the lines to be parallel, we need these to be congruent by the converse. So 2x plus 1 equals 3x minus 5, and then we want to solve. So 1 is equal to x minus 5, and 5 added to both sides is going to get us x equals 6. So in order for m to be parallel to n, x has to equal 6. And that would be, again, I'm going to go ahead and label that alternate interior angles, converse, that we're kind of using there to help prove that.